Okay, hello everyone. Again, let's continue to see exploring small study effects. That means simply assessment of publication bias, again with the use of contour enhanced funnel plot, which is really very important again. Where previously we have seen assessment of publication bias using a standard funnel plot, and now let's proceed to see again assessment of publication bias using a contour enhanced funnel plot. Contour enhanced funnel plot, previously we have said that the symmetry of the funnel plot could be because of two reasons. One, because of publication bias, and the second one is because of other reasons, like, for example, heterogeneity between the studies. Okay, if the funnel plot is asymmetrically distributed or non-symmetrically distributed, the reason could be either of the two. One, because of publication bias, and two, because of heterogeneity between the studies. So how could we identify that symmetry is because of publication bias or because of heterogeneity between the studies? So by the use of contour enhanced funnel plot, we can identify really whether the symmetry is because of publication bias or because of heterogeneity between the studies. So really, this contour enhanced funnel plot is very fundamental for identification of the symmetry of the funnel plot. Is it because of publication bias or because of heterogeneity between the studies? That is really very important. The standard funnel plot only indicates whether there is asymmetry or not. But the reason could be either of the two, because of publication bias or because of heterogeneity between the two. Uh, because of what? Either of these two reasons, because of what could not be identified by a standard funnel plot. But by the use of contour enhanced funnel plot, we can identify whether the asymmetry of the funnel plot is because of publication bias or because of heterogeneity between the studies. So this is an advanced way of assessment of publication bias, which is said to be a contour enhanced funnel plot. So the so-called contour enhanced funnel plot can help to determine whether the symmetry of the funnel plot is because of publication bias or not. We can identify exactly the symmetry of the funnel plot is because of publication bias or because of other than this publication bias. Can be identified by the use of this contour enhanced funnel plot technique. So the contour lines that correspond to a certain level of statistical significance. That means a 1% statistical significance, 5% statistical significance, and a 10% statistical significance. That means in terms of confidence interval, 99% confidence interval, 95% confidence interval, and 90% confidence interval. Of tests of individual effects are overlaid on the funnel plot. So we'll have three levels of significance: 1%, 5%, and a 10% of level of significance alpha. What could be the probability of rejection rate from publication? So generally, publication bias by the use of this contour enhanced funnel plot is suspected when small studies are missed in the non-significant region at the 1% statistical level of significance, at 5%, and at 10%. Especially if these small studies are missed from the non-statistically significant region. That means in between greater than 5 and less than 10. In between these two level of significance. If the small studies are rejected in this region, that means there is publication bias. There is publication bias. So it is really very important. So we'll see how to do that. Let me just show you this contour enhanced funnel plot. So these are different levels of statistical significance. For example, this color is in between 1% and 5%, and the second one is in between 5 and 10%, and the dark one is greater than 10% level of significance. Especially if studies are missed in this region, in the dark region, greater than 10%, and in between 5 and 10%, in between these two regions, over here and over here. In the left side of the vertical line, that is the pooled overall estimate, if small studies are missed from this dark region, and somehow this region that means in between 5 and 10% and greater than 10%. If small studies are missed from this region, from this non-statistically significant region, it is clearly an indication of there is publication bias. So if small studies, that means studies with small sample size, are missed at the bottom of the funnel plot in the region of greater than 10% and in the region of between 5 and 10%, clearly this is an indication of publication bias. This is an indication of publication bias. So that is the purpose of using a contour-enhanced funnel plot in order to identify clearly that whether the symmetry of the funnel plot is because of publication bias or because of other reasons. So from this plot, we can see that the reported effects of almost all small trials at the bottom of the funnel plot are statistically significant at 5 regions in this area. On the right side of the funnel plot, these are very statistically significant, you see, at the bottom, small studies. But on the left side, small studies are missed over here, both in the statistically significant and in the non-statistically significant region, which is an indication of publication bias. Those with a small sample size but with statistically significant result had been published on the right side. But those with small studies and statistically non-significant result are missed from the non-statistically significant and statistically significant region of the funnel plot, which indicates that there is a publication bias, you know. So on the other hand, a fair number of the larger trials at the top of the funnel plot reported a statistically non-significant result. Because even though they are statistically non-significant, since the sample size is larger and since the confidence interval is precise, they had been published, even though they are not statistically significant. But those with small sample size and with statistically non-significant result, they are missed from publication. So that is an indication of publication bias, you know. Okay, for the panel plot to look symmetric with respect to the reference line, that is the vertical reference line, we should have observed some trials in the middle and in the bottom of the dark region, the rejection, that is the statistically non-significant region. That's the p-value of 10% and above. So, but there is no dot or there is no study which had been indicated in the dark region. So this suggests that we are missing some of the small trials with non-significant results, which could be or which would be consistent with the presence of publication bias. So this is a clear indication for publication bias. So now let's see how to do this contour-enhanced funnel plot in the Stata window. In the Stata software. I do have a similar dataset that have already been used for standard funnel plot analysis. So click on statistics and then go to meta-analysis again. So this is a window for meta-analysis. And since the data has been already declared as a metadata, just I need to click on the publication bias window over here. Publication bias. Now, the publication bias funnel plot is similar, but the one that I need to just choose is click on the main window. And again, instead of the standard funnel plot, I need to just choose contour-enhanced funnel plot. Contour-enhanced funnel plot, and again, I need to specify significance contours or level of significance in the box given over here. 1%, 5%, and 10%. So you need to write number 1 over here and then press the space bar once, write again 5, and again hit the space bar once, and again write number 10. Now we give level of significance 1, level of significance 5, and level of significance 10. So you write 1 and then hit space bar once, 5, and then hit space bar once, and again lastly you need to just write 10. So these are the two-sided. The two-sided should be just accepted as a default. And if you want again, you can just click on options and you can just choose graph options, the color, whatever. But I don't want to just do anything over here. So I will accept the default as it is. So click on submit again. So similar result is displayed over here, you know, the ones that we have already seen in the PowerPoint. You see, this is a vertical line, the pooled estimate of the effect size. Those studies on the right side of this vertical line are those with statistical significant result. At the top, they are with a larger sample size. At the bottom and at the middle, they are with a small sample size, but they are still statistically significant. Even though they have a small sample size, since they are statistically significant, they had been published. They had been published, you know. Even there is no study in the dark region over here, in the right side even. Non-significant result, those studies with small sample size and again with statistical non-significant result were rejected, even in the right side. In the left side, studies with a larger sample size, even though they do have a statistically non-significant result, they had been published because they do have a larger sample size. But studies with small sample size and with statistically non-significant result are missed from the statistically non-significant region and even in the statistically significant region because they do have a statistically non-significant result. Since they are statistically non-significant and they do have a small sample size, they had been rejected from publication. So clearly this is an indication for publication bias. It is not because of some other reason. The symmetry of the funnel plot is not because of heterogeneity between the studies. Rather, it is clearly because of publication bias. It is clearly because of publication bias. You can see the level of significance in between 1 and 5%, the level of significance in between 5 and 10%, level of significance greater than 10%. And these dots are the studies, the individual studies, and the vertical red line is the pooled estimate. The pooled estimate or the estimated value of the outcome variable. So this is a way how to just do a publication bias using a contour enhanced funnel plot. So this is what I want to show you here. And the coming videos, really, again, I am eager to show you how to assess. Actually, this standard funnel plot and contour enhanced funnel plot assessment of publication bias are subjective because they are graphical display. But there are objective ways of assessment of publication bias. So objectively, how do we assess whether there's publication bias or not? So the techniques of objectively assessing whether publication bias or not is by the use of Harvard regression-based test, Peters regression-based test, and Eggers regression-based test. And really, I'm eager to show you how to do this. And in the coming videos, I will do this issue. So please just don't forget to just share, subscribe, and like my YouTube channel for those individuals who could be just benefited from this issue. And then we'll continue to do a sensitivity analysis. And again, leave one out study or leave one out meta-analysis for sensitivity analysis, and trim and fill analysis for addressing publication bias. And as I have said before, lastly, I will show you an individual patient level data meta-analysis and a network meta-analysis. So these are the issues that are just waiting for you to just come. For today, let me just stop over here. Thank you for watching. Have a nice time. Goodbye.